Today we're talking about subsets, proper subsets of items. So, set A is a subset of set B if all of the elements of set A are also in set B. Okay? So that's the rule of a subset. If the elements of whatever you've identified are also elements of the other set. So, can a set be a subset of itself? Based on that rule. You just have to have elements of one have to be elements of the other. So could a set be a subset of itself? Yes, it can. However, it cannot be what we call a proper subset. Okay? Proper subset is there would be other elements of B that are not in A. Okay? So all of set A is a subset of B, but B also contains additional elements. So for example, natural numbers versus integers. So our counting numbers starting at 1 versus integers, positive, negative numbers, and 0. So the natural numbers is a proper subset of the integers. Because all natural numbers are integers, but integers also includes negative numbers. Okay, so that's what we're dealing with here. Now, listing out all subsets, all available subsets. So want to make the distinction here. We are listing all subsets versus listing all proper subsets. So all subsets include the original set. So we have reading materials available in the airport shop. So when listing out just subsets, I would start with all of the original set. And then I start listing the combinations if I take one element away. So I have newspaper and magazine. I have magazine and book. And I have newspaper and book. Those are all subsets with one element removed. Next, all the subsets with two elements removed. And last, all elements removed, the empty set. So there are 8 subsets for the available materials in the shop. So then we're going to go with you flip a coin. What list the possible subsets of the options when you flip a coin? So we can start with the original set. Again, possible subsets. So making a distinction between just subsets versus proper subsets. Proper subsets, I would not list that, the heads, tails. We can get just heads. We have just tails. And we have the empty set. So the last 3 are the proper subsets. The first one is not a proper subset, because it's the original set. I know, okay, great. All right, so we are looking at 4 common political parties. There more than likely are more, but these are most of the 4 common ones that show up. Democratic, Green, Libertarian, and Republican. So determine if the following sets are proper subsets of the original. So set M, Democratic, Republican. Is that a proper subset of the original? Yes. Democratic and Republican are elements of the original set, and it's a smaller set of the original. What about set G? Yes. Green is part of the original. What about set V? No. Set V is a subset, because a set can be a subset of itself, but it is not a proper subset, because set V has the exact same elements as the original, just not in the same order. All right. So we have some legendary Pokemon. I did not create these examples. So give an example of a proper subset containing 1 member, 3 members, or no members. For one member, you can list any one of the four. For three members, any of the three. There are no members. And do that. Questions on something being a subset versus a proper subset? Okay. All right. Symbolic set notation. So instead of just identifying a proper set, we're going to use notation of something. So A, for example, is a proper subset of B. That's what that says. It's kind of a sideways long C. Kind of weird symbol. So what that says, A is a proper subset of B. The other notation, if they're the exact same set, you would have that sideways symbol with an underline, meaning A is the exact same set as B. Meaning A then is technically a subset of B, but also identifying that it's the exact same thing. Okay. So we have set S includes all four suits: spades, hearts, diamonds, clubs. Set R are the red, the hearts and the diamonds. Set B are the black, the spades and the clubs. Set C is just the clubs. So if we look at set S and set B, which one is the smaller set? B. So just highlight these right now. That's the one we're talking about. And this is the one we're comparing it to. So set B does not include all of set S, but are the elements of B in S. So then B would be a proper subset of S. So that's what that represents symbolically. Set B is a proper subset of S. See what you can do with the next two. Compare C and B and R and R. So B includes spades and clubs. C is just clubs. So C is a proper subset of B. set R and set R are the exact same set, so they are equal because they're the exact same set. What about number 3? We have the natural numbers starting at 1, 2, 3 and keeps going. And we have the even numbers, 2, 4, 6 and on. So do we have the exact same set? Or is one a subset of the other? So in other words, does one have elements that are not included in the other one? Are we missing elements in one of them? Okay, so even numbers do not include 1, 3, 5, 7. So even should be a subset of the natural numbers, and if you don't quite get the symbol for natural numbers on there correctly, it's fine. I'm not very particular about it. It's a pain. All right. So instead of just listing the number of subsets, how many would we actually have? So from last lesson, that right there is the cardinality of your set. In other words, how many elements are in the set? So empty set has how many elements? 0 elements. So if it's an empty set, there's still one subset. So that even works there. So the number of subsets. So we've got 5 leading scorers in the NBA. It's probably pretty close to accurate still. There would be 2 to the 5th power because that set has 5 elements in it, meaning there are 32 subsets that you could create. 32 different ways to combine all of those people, starting with the original set and taking an element away each time. Top 4 best-selling albums of all time. We've got Michael Jackson's Thriller, the Eagles' Hotel California, the Beatles' White Album, which is probably the one still up there, and Led Zeppelin's 4. I don't know if it would still be up there or not. So again, 4 items, 16 subsets you can create with that. Snap, crackle, pop, the name of the sound your Rice Krispies make. Although much better as a Rice Krispie treat with M&Ms. Just saying. So there are 8 subsets. So if we go back to where we were creating the subsets, on this very first example, there are 3 items you can get from the shop we were able to create 8 different subsets that includes the original set and the empty set. Okay. All right. So if we look at the top 9 tennis grand champions, how many subsets could we create with that list? Again, how many? You don't actually have to create them. I just want to know how many there would be there. So we have 9. There would be a list of 512 subsets out of that. Okay. Equivalent versus equal. Remember from last time? Equal, exact same sets. Equivalent just means the sets have the same number of elements. Okay. So natural numbers with multiples of 3, 3, 6, 9, and so on, that would be the roster method for listing that out. If we're going to use set builder, you always identify what letter you're representing that with. The formula for multiples of 3 would be, we're going to multiply n by 3. So we're going to multiply n by 3. We're also identifying the fact that n represents a natural number. So what would that look like if we're dealing with the multiples of 5? Again, roster method, 5, 10, 15, and the ellipsis to continue that. Again, using set builder to describe the set versus listing the elements out of the set. Okay. All right, so last part, these last 4. So we have a restaurant that offers a deal. You can select 2 of the options for $6. You can do a combination. You've got chicken sandwich, fish sandwich, cheeseburger, or 10 chicken nuggets. We've got 2 friends that are going. Create 2 equivalent but not equal subsets. In other words, the 2 subsets have the same number of elements, but not necessarily the exact same elements. You could have overlap with one of them elements, but not both. So for example, Javier, maybe he wants the fish sandwich. And the cheeseburger. And Michael maybe wants the cheeseburger. And the chicken nuggets. Again, they each have two elements, making them equivalent subsets, but they're not equal because there's a difference between what's in them, the kind of element. So Serena and Venus walk into the same restaurants, but they order the same pair of items, resulting in equal sets of choices. If Venus ordered a fish sandwich and chicken nuggets, what did Serena order? Again, making sure we know the difference between equal versus equivalent. And we'll finish these last three when we get back from lunch. Okay. So, if Venus ordered a fish sandwich and chicken nuggets, what did Serena order? If the two sets are equal, exactly. She ordered the exact same thing. So Serena ordered fish sandwich and chicken nuggets. So that doesn't necessarily need to be in the set because they didn't ask what the set is, they just asked what she ordered. If you have it in the set, that's absolutely fine. So the next two, we have the students listed on the players listed on the volleyball team. Obviously, you only have 6 players at a time on the court. So create 2 possible equivalent starting lineups of 6 players that the coach could select for the next game. Again, equivalent means they have the same number of elements, just not necessarily the same elements. And then 7, we want equivalent subsets for a captain and an assistant captain. So create the 2 subsets for each question. So your first set has 6 players. your second set, as long as one player is different from the first set, and you have 6 players, it's equivalent. So all I would have to do is just change one player out. So then if we're dealing with a captain and an assistant captain, we could have Angie and Maya. I could also have Angie and Penny. Again, some of the elements can be the same when you are looking at equivalent subsets, but as long as at least one element is different, it's fine. All right.